Hello guys, this video is about formulas in three dimensions. We will be talking about three-dimensional figures, the solid figures. And this is chapter 1, section 6, talking about polyhedrons. Polyhedrons are three-dimensional figures formed by four or more polygons that intersect only at their edges. So let's take a look at the given examples. The first set of examples, we see here a rectangular prism. All its faces are rectangles. So this is a polyhedron because it's formed by polygons. Rectangles are polygons. The second figure, you see the base is parallelogram or rectangle. The faces are triangles. So this figure is also formed by polygons. So this is called polyhedron. The last figure in the first set is when you see the faces, you see triangular figures. So the triangle is a polygon. So this figure is formed by polygons. So we can say this is a polyhedron. But when you look at the second set, you see a cone, a cylinder, and a sphere. They are not formed by polygons. The circle is not polygon. The round shapes, round figures are not polygons, so they're not formed by polygons, so they're not polyhedrons. Okay, and when we talk about polyhedrons, we're going to talk about the number of edges, number of faces, number of vertices. So let's talk about these elements, vertex, edge, and face first. Face is each flat surface that makes up the polyhedron: the top face, bottom face, side faces, up face, uh, back face, front face, and edge is the sides of the polygon, each polygon, and vertex is a point connecting two sides, two edges. So those are the elements of each polyhedron. And when we talk about three-dimensional figures, about their edges, vertices, and faces, we can talk about a formula, Euler's formula. The formula says you take any polyhedron, any solid that has flat faces, we can think of all, and it turns out that we are always going to get 2 when we add vertices to faces and subtract off the edges. So this is what Euler formula says. So count the number of vertices, subtract off the number of edges, and add back the number of faces. You'll always get 2. It's an amazing formula. Um, this is extremely easy. We will be asked to find the unknown number of one of the number of faces or number of edges or number of vertices. 2 of the elements will be given. The one of them will be missing. By just using the formula, we'll find the unknown. Or the questions will give us a figure like this. It will ask us to count number of faces, vertices, and edges, and verify the result by using Euler's formula. So let's start solving some questions. It will make more sense. So the first example, find the number of vertices, edges, and faces of each polyhedron. Let's start from number of vertices. How many vertices do you have for figure A? Vertices. Let's look at the connection points between the sides. Here we have 1, here we have 2, here we see 3, here we see 4 vertices. Number of vertices is 4. What about number of edges? This time we're gonna count the sides. 1 side, 2 sides, 3 sides, 4 sides, 5 sides, and here at the back we see one more side, 6 sides. And lastly, we'll talk about faces. Number of faces. We see two front faces here. One face, two faces, and we have one at the back. We have one at the back. 3 faces, and one at the bottom. One at the bottom. 4 faces. So the second part of the question says verify the result by using Euler's formula. So these are what we found. If we want to make sure that we got them correctly, we can use Euler's formula. The formula was V minus E plus F equals to. Does it verify? Does this work for the outcome that we found here? Let's put them all back, substitute them back into the formula. Number of vertices is 4 minus number of edges is 6 plus number of faces is 4. Is that equal to 2? Let's see. 4 minus 6, negative 2. Negative 2 plus 4, 2. 2 equals 2. Yes, it's correct. So what we found here are correct. So it applies the formula. What about the second question? We do the same in the second question. Find each element one by one. Number of vertices. 1, 2, 3, 4, 5 vertices here. Another 5 here. So we totally have 10 vertices. Number of edges. Let's count the sides. 1, 2, 3, 4, 5 sides here. 5 sides on the other side. And we also have the lateral sides. 5 makes 10. 11 here. 12. 13, 14, 15. So we totally have 15 sides. And about the faces, let's take a look at the faces. How many faces do you see here? Here we have one pentagonal face here, the other pentagonal face at the back, 2 faces, and 3 faces, 4 faces, 5 at the bottom, 6 at the back, 7 at the upper left. So we totally have 7 faces. So let's verify this by Euler's formula. Apply the Euler formula. V minus E plus F equals to. Does it satisfy? Does we found what we found here satisfy the formula? Let's see. Number of vertices is 10. 10 minus number of edges is 15 plus number of faces is 7. Is that equal to? Is that equal to 2? Let's see. 10 minus 15, negative 5 plus 2, 7, 2 equals 2. So it verifies the Euler formula verifies what we found here. So this is how we solve this kind of questions. So we will be given a figure, ask us to count the number of faces, vertices, edges, and verify it by the Euler's formula. Or without given a shape, like in question 29, 30, 31, we will be asked to find the missing element here. So let's try 29, exercise 29. Exercise 29, the number of vertices is given as 8, number of edges is given as 12, number of face is missing. So the formula was V minus E plus F equals 2. So let's see if it works here. V is 8, number of edges is 12, number of faces is missing equals 2. So 8 minus 4 are 12, negative 4. Negative 4 plus number of faces is 2. Bring negative 4 to the other side. F is 2 plus 4, which is 6. So we totally have 6 faces. That's it.